Okay, so these are inverse trig problems, and they require you to understand the unit circle.
Mm-hmm.
All right, so I know on the unit circle, the most important quadrant to understand is quadrant 1. Because if you understand quadrant 1, then you can kind of figure out the other ones. All right, so what degree is this right here?
1.
This is 0 degrees. So it's like opening up, opening up, opening up, and this is 90 right there. All right, so then if that's 0, what is that? If this right here, if this is 90 degrees right here.
It's half of 90.
Mm-hmm.
45.
45. So this is 90. All right. And what is this one right here? It's one of the special ones you have to know.
Does it have like square root in it?
I'm just talking about degrees. Like, so this is, that right there is 45 degrees, right? This is 90 degrees. This one is going to be...
Is it half 45?
It's going to be 30 degrees.
Oh, and then 60, right?
And this is 60.
Yeah.
And basically, it's going to be the same angles that are on your special right triangles. So you have your 45, 45, 90. Right, so 45, 45, 45, 90. And then what's the other special right triangle? Do you remember?
30, 60, 90.
30, 60, 90. All right. Which side do you think is 30? Which angle? Why?
Yeah, it's smaller.
Mm-hmm. Because it's opposite the smaller side. Do you get that?
Mm-hmm.
All right, so that's 30 degrees. That's 60 degrees. All right, so special right triangle review. What is, let's see, if this is x, do you know what that is right there?
Is it also x? It's
also x because a 45, 45 triangle, 45, 45, 90 is isosceles. So the two sides are the same. All right, do you remember what this one is?
Is it like x times the square root of 2?
Perfect. And you could actually figure that out with the Pythagorean Theorem.
Mm-hmm.
So it's x times it's x times the square root of 2. All right. And I always tell students, like, if there was only one to actually teach, like, I think everybody would get it on the first day, and it'd be put into the easy category.
Mm-hmm.
But this one throws everything off. Once I introduce this one, it kind of screws up the learning of this one.
Really?
Yeah, because, and I'm bringing that to your attention so you can kind of remember that it's weird. Because this one here, the root belongs in the hypotenuse. But on this one, it doesn't.
It's on the longer side, right?
It's on the longer side. And if you think about it, let's say we're comparing like 1, and then we're comparing 1 times the square root of 3, and we're comparing 1 times 2. Which side, or which of these values is the largest value?
1 times 2.
Yeah, so that's the largest. Where's the smallest?
1.
Mm-hmm. And this one's the one in the middle.
Mm-hmm.
So the root is the middle one. And which side here is the middle side? The middle length side.
The left side.
Mm-hmm. The one opposite the 60. So if the shortest side is x, this over here is twice x, and this is x
square root of 3.
X root 3. I don't confuse this, the 2 and the 3 over here, because I remember that at least the 30, 60, 90 has a 3 in it. So I know it's that. But just know that the root does not belong on the hypotenuse.
Mm-hmm.
Okay. So we got these values right here. And we have let's say we have a 30 degree angle right here, right?
Yeah.
So we go like this, go straight down right there. And so this angle right here is 30 degrees.
Uh-huh.
Okay. Now, the important numbers you have to know, and you can kind of help to memorize them, are these numbers, which is root 2 over 2 and root 3 over 2, 1/2, 1, and 0.
It's coming back.
Those are the popular ones.
Yeah.
And the way those come about is they're actually the lengths along the unit circle. So this is called the unit circle.
Mm-hmm.
Do you know why it's called the unit circle?
These are each like a unit long. And it's a circle.
What's a unit long?
Is it the line? It's like all one.
Yeah, that's right. The radius is 1.
Yeah.
They could call it the 1 unit circle. So the radius is 1. Okay. So let's kind of zoom in on this one right here. All right. So if this is 1, all right, and that brings us to like, well, first of all, this is 30, right?
Yeah.
And this has to be 60.
Mm-hmm.
All right, and when you do a 30, 60, 90 triangle problem, the easiest one you could possibly do is one where, let's say this is 30, 60. They say this is like 7. All right, if that's...
Oh, and then like...
Isn't
that... that's what I was looking. I was like...
You can never trust a picture. You always trust numbers.
I was like staring at it when you were saying the 7.
All right, so that's 7. All right, so what would this be right here?
2 times 7. 14.
14. What would this be right here?
7 root 3.
7 root 3. All right. Now let's reverse the process. So let's say we're given that that's 7 root 3. So the way you find, so you always want to go from the middle one to the short one. Okay. You don't want to go from the middle one to the hypotenuse.
Well, like, does it matter the order? Because wouldn't it just be the same value either way?
Well, it's just easier to go from here because then once you have this number, you can double it and go there. True. So, and then what you do from here is all you do is you just divide it by the root that you have to know about. So this will be 7 root 3 over root 3. So if I have a 45, 45, 90 triangle, 45, 45, and I say this is 5, then I know what this is. It's 5 over root 2. See, and then to go back to this, it'd be 5 over root 2 times root 2, bam, 5. So it's harder to go back. It's always easy to go from the side to the hypotenuse or from the...
This is 5 over root... Or is it 5 times root 2 over root 2?
No, it's actually 5 over root 2. So this answer is 5 over root 2. See, so let's say this answer was like 3. Let's say this side was 3.
Oh, I get
this would be what over here?
3 root 2.
And if that's 3 root 2 and you want to go back to it, it's you divide it by root 2. So it's whatever's here over root 2. Okay, so...
Sorry, I was thinking of this as a 30, 60, 90 again.
Yeah, it's weird. So for this, you're actually better off just kind of memorizing that. Mm-hmm. Like, all right, this is the one that involves the root 2 on the hypotenuse. If I want to go to the side, just divide it by the root 2. All right, same thing here. So if you have this, and you want to go over here, you just divide it by
root 3.
Root 3 takes you back to 7, right?
Mm-hmm.
All right. So we are here. We have a 1 on the hypotenuse, right?
Yeah.
Well, okay. After all that, so what is this going to be?
1.
It's definitely not going to be 1.
Oh wait, actually no. Yeah, I'm tripping. It would be 1/2.
That'll be 1/2. All right. And
then this one's root 3.
It is...
No. Root 3 over 2.
That's right. It's root 3 over 2. Actually, doing this, you don't actually even have to reverse the process. That's really a whole other lesson. But that's a 30, 60, 90 lesson. All right. So that's that. Got that?
Yeah.
All right. Now look over here. Let's talk about this one over here. We're going to focus on this one. All right. Well, something I know for sure on this thing. It is called the unit circle after all.
Mm-hmm.
All right. So what's this right here?
1.
1. All right. Oh, and what's the angle?
45.
And we are going to use our new skills. Okay, so now, oh no, we're going from the hypotenuse to a side. Just like over here, we had to go from our hypotenuse to a side.
Mm-hmm.
So
Wait, what are you asking? Sorry.
What's the side? Like, let's say this is 5. What's this going to do right here?
Oh, 5 over root 2.
Right. Let's say this is 1. What's this over here?
1 over root 2.
1 over root 2. All right. So let's go over here and let's say that's up here. Let's say that is 1. What's this over here?
1 over root 2.
All right. 1 over root 2. And then you rationalize it. So times root 2 over root 2.
I was just looking at the answer. Would be root 2 over 2.
Yep. Root 2 over 2. And what's this one over here?
1 second. 1. Oh, root 2 over 2.
Because it's isosceles. Right? So these two angles are the same.
So this
So
is
that
the same
side
as
is the same as
this.
that side.
Oh, you're right. Yeah, I remember that.
Root 2 over 2. Got that?
Mm-hmm.
All right. Now let's look at this one over here. Bam. This one's 60 degrees.
I was going to say, I thought this is 1 because it's that, but then it gets cut short because
Correct.
of the line down.
Yes.
Okay.
So this distance right here.
We'll cut it.
Yeah. So this distance right here. That's a good point. So the length. I'll just be obnoxious there. This length right there is root 2 over 2, which is under 1.
Mm-hmm.
Root 2 over 2 is 0.7.
Oh, it's close.
It's not quite 1 because 1's the radius, and this is not quite the radius.
Yeah. Okay.
All right, so now we're going to do the 61. So all right, so this is, what degree is this right here?
60.
All right, 60 degrees makes this 30 up here. We know this length. What's this length right here?
1.
That's 1. Okay. And what is, well, what's this length?
1/2.
1/2. And, well, what's this length up here now?
Root 3. Wait, no. Root 3 over 2.
Good. Root 3 over 2 because you have to multiply root 3 by the short side. You with me?
Yeah.
All right. So let's kind of look at some triangles here. Let's see. Okay. One of these sides, I'll give it a side X or Y. One of these sides has a length of 1/2, and the other one has a length of root 3 over 2. Well, which is which?
This is a 30, 60, 90.
Yes. But it doesn't really matter because I'm telling you one of them is 1/2 and the other one is root 3 over 2. So you just have to, do you know what root 3?
1/2 is the Y.
Yeah. Because root 3 over 2 I think is like 0.8. It's almost like 1.
Mm-hmm.
So this is 1/2. And what's this over here?
Root 3 over 2.
All right, so this is root 3 over 2. Okay.
The top is 1.
This is 1, yeah.
Okay.
All right, so let's look at our unit circle again. And it really helps to know one value would save you a lot of work, big hassle. I know it because the only reason I know it, actually, and I've taught this for many years, is because I had a student who said, my teacher thought I wasn't paying attention. And my teacher was like, hey, what's the sign of 30? And then I showed him this thing with a hand, and he was like, did it on the table, and he was like, 1/2. And then the teacher was like, okay, fine. But then what I thought of when he told me that story was, well, I don't know the sign of 30. I would have to do the hand thing too. And because of that, it stuck with me.
It's easier.
So I was like, I kind of felt like I was him being called out, like, oh man.
What's sign 30?
So I know that one. And that helps me out a lot. So sine of 30 degrees is 1/2. Okay. And I'll tell you why that helps me out. Well, first of all, sine is all about the y. All right? Sine is all about the y-axis.
Mm-hmm.
Okay? Sine's the height. Cosine is all about the x.
Oh, because it's adjacent.
Okay, so cosine, so this right here, so this distance right here, from here to here, is actually cosine of that angle. And this distance from here to here is the sine of this angle. You with me?
Yeah, I kind of remember that.
Okay, so the sine, oh, by the way, what comes first in the alphabet? S or C? Or, yeah, S or C, C.
Yeah.
And then X or Y?
X.
See if you kind of remember like that too.
Yeah.
Okay. Well, what did I get called out on and I'll never forget? I didn't really
Wait,
get called
what?
out.
Sorry,
what was
what?
the thing that the kid was called out on? And then,
Sine of 30.
Is what?
1/2.
Yeah. So that tells me that this is 30 degrees. This is 1/2. But it doesn't obviously look longer than this one.
Mm-hmm.
All right. So this length right here is √3/2. All right.
Mm-hmm.
So just from this part here, since I know that this is the cosine length, I know that the cosine of 30 degrees is √3/2. All right, which is 0.8, right? And the sine of 30 degrees is
1/2.
1/2. All right, we go over here, and you have the opposite situation. So you go over here, and this is 60 degrees right there. So I'll do it over here. Well, this is short, and this is long. Guess which one gets the 1/2, and guess which one gets the √3/2.
The short.
So this is 1/2, and this is √3/2. So cosine, is that side by side or up and down?
Side by side.
Side by side. So that's 60 degrees. Bam. So what's the cosine of 60 degrees?
1/2.
Cosine of 60 degrees is 1/2. And the sine of 60 degrees is
√3/2.
√3/2. But I didn't need to circle at all for that. Because I know this. I know that the other one is the opposite.
Mm-hmm.
Okay, the other one is cosine of 45 degrees. My personal favorite.
Really?
Yes, everyone has their own. With time, you'll have your own. So this is 45 degrees.
Favorite angle.
Take it with me everywhere. So 45 degrees, because the cosine and sine are exactly the same.
Mm-hmm.
So this is √2/2, and this one over here is √2/2. Now, what would you say that this length is? What would you say that this length is, right? Right here.
1.
1. All right. So here's an angle, and here's a smaller angle, and I don't know why I did it like that. And there's a there's an angle, and there's a smaller angle, and then there's a smaller angle. And if I collapse completely, what's my degree?
0.
0. So here's 0 degrees. All right. So this, by the way, this is, let's say this is like one degree, right?
Okay.
What's going to be really small, sine or cosine?
Sine.
Right, because sine is all about what?
The y.
The y, right? Okay, so when it's fully collapsed, what is that height going to be? Here's my fully collapsed triangle.
0.
So sine...
Or like, would it be like...
0. So sine of 0 degrees, you have a fully collapsed triangle. This is right before that, right? And then you collapse it completely, you have no height. So sine of 0 is 0. And it's better to just think about that. You can picture the inner circle in your head and be like, oh, wait, that...
It would never...
Yeah, so like, you can even ask yourself, like, if you put your unit circle on your, like, Cartesian grid, so that's like 1, that's -1, that's 1, that's -1, and you go like this is, believe it or not, a perfect circle. And you go like that. All right, so what is that coordinate?
Which coordinate?
Right there.
1, 0.
1, 0, right? And this is your x, and this is your y, and your sine is your y coordinate, right? So what is the sine of 0 degrees?
0.
What is the cosine of 0 degrees?
1.
Good, because the cosine of 0 degrees is 1. All right, so we go over here, go like that, go like this. All right, so this is 90 degrees. What is this coordinate?
0, 1.
1. All right, so this is x, this is y, this is 90 degrees. What is the cosine of 90 degrees?
1.
Cosine of 90 degrees?
No, 0.
Yeah, because you have no side by side, right? 0. And what is the sine of 90 degrees?
1.
Is 1. Let's go all the way to 270. So all the way over here. Bam.
0, -1.
You have 0, -1. What's the sine of 270?
-1.
And what is the, let me think about that. Yeah, the cosine of 270. Now let's say we're over here. What's the cosine of 180 degrees?
Cosine would be -1.
Good. What's the sine of 180 degrees?
0.
Correct. Okay, now let's go over here. And we're going to go ahead and say this is 45 degrees. So we're going to mentally think of being over here. And let's just get these coordinates down. What would these coordinates be?
It would be 1, or no, root 2 over 2.
Root 2 over 2, comma,
Root 2 over 2.
root 2 over 2. But now you're on quadrant 2. So what changes sign? Your x or y?
Your x.
Your x. So you got root 2 over 2, negative 2 over 2, right?
Comma root 2.
Comma root 2 over 2. And that is 135, I think, right? 135.
What is?
That angle.
Oh.
Right there. All right. So what's the sine of 135 degrees?
The sine is root 2 over 2.
Yep. So the sine of 135 degrees, because it's positive, is root 2 over 2, and the cosine
is negative root 2 over 2.
Of 135 degrees is negative root 2 over 2. Okay, now let's talk about tangent really quick. Tangent is the same exact thing as, like, tangent of some angle is the sine
over
cosine. And then cotangent, by the way, is, it's cosine over sine. All right, so if I'm going to do the sine, let's say that I want to do the tangent of 30 degrees. Well, that's the sine of 30 over the cosine of 30, but I know the sine of 30 because I was super in my head embarrassed I didn't know it. So what's the sine of 30 degrees?
1/2.
1/2.
What is that hand thing, by the way?
I'm going to show you.
Okay.
1/2 over
root 3 over 2.
Okay, root 3, over root 3 over 2. So then you go 1/2. I like to do a little in between third grade step, divided by root 3 over 2. Then 1/2 times 2 over root 3. Why which is 1 over root 3. Then rationalize
root 3
1 over root 3, and then that, you're going to get root 3 over 3. So the tangent of 30 degrees is what?
Root 3 over 3.
All right. So then what is the cotangent of 30 degrees?
3 root 3 over 3.
So did you flip this one?
Yeah.
And then you rationalized?
Oh, wait, no, so it'd be just
Right, root 3 over, like that, right?
Yeah.
So then it's...
It would just be 3 root 3.
Wait, why am I so... Wait, we have 3 over root 3...
Times root 3 over root 3.
Times root 3 over root 3.
And then you can simplify it after that.
So it's 3 root 3...
Over 3.
Over 3. Oops, wrong one wiped.
Yeah.
Which is root 3.
Yeah.
Right? So the cotangent of 30 degrees is root 3. So if you have a problem that's like the cosecant of some unknown angle is root 2. Well, I don't know anything about cosecant. What I do know is that trig exists like in like opposite universe. So what I mean by that is, here's cosecant, here's secant, and here's cotangent. And I would love for this to correspond to cosine, because that would be awesome. But we're in opposite land,
Yeah.
So that's the same as 1 over sine. And I would love this to correspond to sine. But we're in opposite land, so it's 1 over cosine. And this is actually the only one that makes sense.
Yeah, I remember I always used to think about that.
1 over tangent. So I can easily go from here to my opposite land buddy and just say, all right, well, then I can make that a fraction. And I can say, all right, the sine of theta, because c goes with s, is equal to 1 over root 2. Now let's rationalize.
Root 2 over 2.
Root 2 over 2. By golly. So where in quadrant 1 do we have a sine? What angle in quadrant 1 has a y value of root 2 over 2?
45.
45 degrees. Theta is 45 degrees. But technically, you have 2 thetas. In this case, let me see here. What do they want you to do? Oh, but they're saying it's an acute angle, because technically if you go over here, what is this? I'll just say like it's whatever. I'm more concerned about that guy. What's the y value? If that's 45.
Root 2 over 2.
That's root 2 over 2. And if I go over here, and I'll just say that's whatever. I'm more concerned with the y value, and that's...
It's still root 2 over 2.
And this reference angle is 45. That's root 2 over 2, right? And you go over here, that's an obtuse angle. So they don't want this one. Because technically, 135 degrees, the cosecant of 135 degrees is root 2. You see, because if they're saying, hey, if the cosecant of some angle is root 2, they're also saying that the sine of some angle is root 2 over 2.
Yeah.
And the sine of 135 is root 2 over 2, and so is the sine of 45, but they only want acute. They only want under 90, so you have to go with 45. Okay? If you want to know, like, the tangent of anything, remember you should divide sine over cosine.
Yeah.
You ready for the hand thing?
Yes, I am.
All right. Best thing ever. Okay, so on your fingers, I used to actually write this on students' fingers.
Oh, really?
So you have to use the left, especially the left hand. All right, so we're on this one right here. So think of your pinky. Your pinky is going to be 0 degrees.
Okay.
All right, and this finger right here is 30 degrees. Middle finger is 45 degrees. Index finger is 60 degrees. Thumb is 90 degrees. Okay, So, remember it's cosine, comma, I'm going to write it at an angle like this.
Cosine.
It's cosine, comma, sine. Okay, and it's x, comma, y. Right? All right. Your pull down finger, this one right here, is your comma. Okay? And so, yeah, so let's say you want to do like and you see how I wrote it like cosine, comma, sine? Anything, so here's your like pull down finger. Here's your pull down finger, right here. Okay. Anything above pull down is cosine. Anything below the pull down is sine. Just like this is cosine. Just like this. So that's cosine and that's sine.
Okay.
All right. So then what you need to know, the only other thing you have to know is root fingers over 2. All right, so watch this. So if you're gonna do the cosine of 60 degrees, you pull down. Actually, let's just do this guy because he's pulling 45. So the cosine of 45 degrees. Okay. Now cosine. We're talking about these fingers up here, right? How many fingers do you have up there?
3.
How many fingers do you have up here?
2.
2. So root fingers. So root 2 fingers over 2. Root fingers over 2. So the cosine of 45 degrees is root 2 over 2.
Wait, that takes me a second.
So palm up. Okay, so like that.
Oh, okay.
So root 2. Don't pay attention.
2.
Don't pay attention to these at all.
Okay.
So just root these guys. Root 2
over 2.
over 2. All right, so let's do 30 degrees. So pull your 30 degree finger. That's going to be this one right here, right? All right, so let's do the cosine of 30 degrees. That's the ones above the pull down finger.
Root 3 over 2.
Root 3 over 2. It actually works. I would do 0. I would do 0 and 90 for my head, visualizing right here, but it works also. So if you do, let's say you want to do the cosine of 0 degrees, pull your 0 finger.
Yeah.
Right? So you're pulling this one. All right, so cosine is above it, right?
Yeah. So
all right, so yeah, root 4 over 2, which is
2 over 2, which is 1.
Which is 1.
Ah.
Right? Now,
for sine.
So when you have like root 3 over 2, right? You can actually put your fingers in position. You can actually put your fingers, you can create, like, if it's cosine, like, the cosine of some angle is root 3 over 2. So you're like, all right, well, I need to have 3 fingers on top.
Oh,
and what's your pull down?
30.
30 degrees. Now, the best part of all, I didn't put a picture of it, but I'm an amazing artist. So here's the back side of your hand. All right, so for tangent, you want to left hand.
What was the sine one? Is it the?
So sine is below. So it's root, like, so the sine of 60 degrees. Pull your 60. What's below?
Root 3 over 2.
Root 3 over 2. So if you want to do tangent, so left hand, palm up, like normal.
Oh, left hand palm up.
All right. Mark your fingers. Mark your fingers like normal.
What do you mean mark fingers?
Like just pull them down like we just did. Like, so your middle finger would be 45 degrees. Okay? 3, flip hand. 4, root fingers over root fingers.
Oh shoot.
So, and this is amazing because you
How did you find that?
you don't have to divide. I tutored with a bunch of kids. Like I tutored like an after-school program at Pally, and I was working with some kids, and there was like this physics guy. And he was tutoring there too, and he was like a grad student. He was like, I remember in high school, my teacher told me this finger thing, and I was like, there's a finger thing.
It's so
And he kind of remembered it, and like I did some research, and so it's amazing because
It's awesome.
let's say you have well, first of all, let's finish the tangent one really quick. So if you have, where did I write that? Hold on. Here. Right, so let's say, like, all right, you want to do like the tangent of 60 degrees. Palm up, pull your 60. All right, cool. Flip your hand. Now you're going to end up with root 3 over root 1, which is root 3. See that?
Oh, you're right. Wait. Oh, yeah, you're right.
Right?
Oh, shoot. Yeah.
Okay. Cotangent, don't flip your hand.
Ah.
Do not flip your hand. You got
So
it.
root 1 over
So
root 3.
so cotangent is still root fingers over fingers. Just don't flip your hand. You see? So if I say, all right, so if I say the cotangent of some angle is 1 over root 3, all right, so I'm going to pull down, so it's root fingers over root fingers, so don't flip your hand, 60 degrees. Bam.
Wait. 1 over 3. Don't flip it. Oh, okay, I see.
Right?
It would be cool is if the flip one was cotangent.
It
That
would be cool,
perfect.
yeah. So, and when I teach kids, I'm teaching you the whole thing because it's on video.
Mm-hmm.
But usually, after this whole explanation, they're just like thoroughly confused. So I usually just do the sine and cosine for a couple weeks. Then I'll introduce tangent. Then I'll introduce cotangent, and then
That's
they got
cool.
it. But yeah, it's super handy because it allows you to go backwards really quickly.
I'm
Like you
gonna
can do.
use that a lot.
So if you go sine of 30 degrees, oh sorry, you say sine of some
1/2.
angle is 1/2. You just have to say
So
sine. It's the fingers below.
Wait, no.
Yeah.
Yeah, this one.
Yeah, right? So
It's going to be 30, yeah.
yeah, so it's going to be 30 because it's going to be root 1 over 2, which is 1 over 2.
Makes sense.
And that's it.
Thank you.
Uh-huh.
I don't know.